All right. On the first set of directions, it says find all degree solutions, and there's no range for theta, which means that you need to make sure that in all these problems you do what? You need to put plus 360 in. All right. These problems here shouldn't be as difficult because you know where sine is a positive square root of 3 over 2. So the first thing you should have done here is draw your pictures. And where is sine positive? Which quadrants? 1 and 2. So it is 1 and 2. And where does sine equal square root of 3 over 2? 60 degrees. So we can figure out what these angles are here. So the way we would solve this is we would say that 2a plus 50 degrees equals 60 plus 360n, and 2a plus 50 degrees equals 120 plus 360n, and then all you have to do is the algebra on that. So we're going to subtract 50. All of these. And you get 2a equals 10 degrees plus 360n. And over here you're going to get 2a equals 70 degrees plus 360n. And then the last thing you have to do is what? Yeah, divide everything by 2. And so you end up with a equals 5 degrees plus 180n. And, that's a comma, 35 degrees plus 180n. All right, same type of problem here, but now we've got cosine as a negative 1/2. So in which quadrants is cosine negative?
2.
Right, to the left. So 2 and 3. And where does cosine equal a half? 60, so that's our reference angle. And then these would be our actual angles here. So now we have 4a minus 20 degrees equals, what's the first angle there? 120 plus 360n. And 4a minus 20 degrees equals 240 plus 360n. Okay? What do we do next? Add 20. And you end up with 4a equals 140 degrees plus 360n, and 4a equals 260 degrees plus 360n. And then your last step is to do what? Divide by 4. And we end up with a equals what?
25.
35
35.
plus 90n and 65 plus 90n. This is a multiple angle problem, but you pretty much solve it the same way we've been solving the other two. So we need to know where cosine is positive, because it's a positive square root of 3 over 2. So which quadrants is cosine positive in?
1, 4.
It's positive in 1 and 4. And where does cosine equal square root of 3 over 2? 30 degrees, that's our reference angle. And then the angles we need to use are these. Okay? So we've got 3 theta equals 30 degrees plus 360n. And we've got 3 theta equals 330 degrees plus 360n. So all we have to do to get theta now is do what? Divide by 3. And so we end up with theta equals 10 degrees plus 180n.
120.
120, sorry. Good, good, good. 120n. And 110 degrees plus 120n. All right, we don't have cotangent on our chart, so what can we do to change cotangent? Yeah, we can flip both sides. So we can, if we flip cotangent, it becomes tangent, and if you flip square root of 3, it becomes what? 1 over square root of 3. Okay? So then we need to figure out where tangent is positive. Which quadrant is tangent positive in? Yeah, it's diagonal, so it's 1 and 3. And then where does tangent equal 1 over square root of 3? 30 degrees. That's your reference angle. So then these are our angles here. And so you've got 2 theta equals 30 degrees plus 360n. And 2 theta equals 210 degrees plus 360n. And so to find theta, all you have to do is what? Divide by 2. So that gives you theta equals 15 degrees plus 180n and 105 degrees plus 180n. Okay, on this problem, you've got sine, cosine, minus cosine, sine. And so you were supposed to recognize that that is the sum and difference identity. So you're doing the right-hand side to the left-hand side. So this is the sine A plus B. Or A minus B, you're right. And the A is theta, and the B is 3 theta. Now, when you subtract this, you get sine negative 2 theta, right? So it would be really nice if you guys remembered whether sine is an even or an odd function. It's an odd function. Anything with sine in it is odd. And odd functions tell us we would take this negative in front of the angle and do what with it? That's the even function when you get rid of it. You move it to the front. So this would be negative sine 2 theta equals 1. And then if I want to get rid of the negative from the front, I could do what? Divide or multiply by negative 1.
It's cosine and it's...
You just get rid of it.
Sine's the only one.
Anything with sine. Tangent, cotangent, cosecant, yeah.
So,
So where is sine negative 1? Down here. Right, so that's 270. Correct? So you've got 2 theta equals 270 degrees plus 360n. Then all you have to do is divide everything by 2. Theta equals 135 degrees plus 180n. Okay, so this is already quadratic, right? So some of you use your calculators and use the ACT program, but I don't have that. So I would let cosine 2 theta equal x, and then just rewrite it. And factor. So you would have saved yourself a little bit of time on that using your calculator. So I have that cosine 2 theta equals negative 1/2, and I have that cosine 2 theta equals negative 1. So I would go to drawing my pictures. So I'll start over here. Where is cosine negative? 2 and 3. And where does cosine equal 1/2? 60. So that's my reference angle. Okay, so I've got 120 and 240 so far. And then over here, where is cosine negative 1? Yeah, 180. Okay? So I've got a bunch of different things here. I've got, is it 2 theta? 2 theta equals 120 plus 360n. I've got 2 theta equals 240 plus 360n. And I have 2 theta equals 180 plus 360n. And so to solve for theta, we just take all of this and divide it by 2. And so you end up with theta equals 60 degrees plus 180n, 120 degrees plus 180n, and 90 degrees plus 180n. All right, for the rest of the problems, it says find all solutions if theta is between 0 and 360, which means all of your answers should just be angles. We don't do the plus 360n anymore. So on this problem here, all we're doing is putting like terms together and solving. So you can add the 2 sine theta over here, and then subtract the 5 to the other side. And you end up with 5 sine theta equals negative 5. And then you would just divide by 5, right? Sine theta equals negative 1. Well, where does sine equal negative 1? 270 degrees. You need to make sure some of you, not very many of you, but some of you are still doing the whole thing where you write down your answer as sine theta equals 270 degrees. Sine theta can't equal degrees. Theta is the only thing that's degrees, so make sure you're not putting the trig function there. All right, same thing on this problem. You're going to put your like terms together, so I'll subtract this cosine theta to the other side. And then I might as well move the square root of 3 over here. So I've got 2 cosine theta equals negative square root of 3. And then what do I do?
Divide by 2.
Yeah, just divide by 2. Cosine theta equals negative square root of 3 over 2. And then we draw our pictures again. So where is cosine negative? 2 and 3. And where does it equal square root of 3 over 2? 30 degrees. That's your reference angle. So then we have 150 and 210. And 210. All right. Number 9. This problem is already factored for you, so you do not need to worry about using the quadratic formula to solve or any of that stuff. You just need to set each of the factors equal to 0. So if sine theta minus 1 is the first factor, then sine theta would have to equal 1, because 1 minus 1 is 0. And 2 sine theta minus 1, that's going to be sine theta equals 1/2, because 2 times a half is 1, and 1 minus 1 is 0. And then we just solve for that. So sine equals 1, where? 90, when you go up. And where is sine positive? First and second. And where does it equal 1/2? 30 degrees. So we have this angle and this angle. So theta equals 90, 30, and 150 degrees. Okay, on this problem, the first thing that you should have done is looked at it and realized that you could factor something out of all the terms. What can you take out of all the terms? Yeah, you can factor out a cosine theta. And when you do that, what's cosine divided by cosine? 1. And what's negative 2 sine theta cosine theta divided by cosine? Negative 2 sine theta. And now you're done. You've got it factored. So you set your factors equal to 0. So you've got cosine theta equals 0. And then what would sine theta have to equal? 1/2.
How'd you get 1?
All right. Where does cosine equal 0?
90.
Yeah, cosine is left and right, so it's 0 when you don't go left and right, so you're going up and down. And then we just did this on the previous problem. Sine is positive in the first and the second quadrants, and the reference angle is 30 degrees. So we have, over here, we have theta equals 90, 270, 30, and 150 degrees. Okay, so on 11, it's 2 sine squared theta minus cosine theta minus 1 equals 0. It's not quadratic if you've got two different trig functions, so what do we need to do first on this problem?
Add cosine.
Change the sine squared theta to 1 minus cosine squared theta. And then everything is in terms of cosine. So you can distribute the 2. Okay? Put our like terms together, so there's 2 in the front and then minus 1 on the end. Okay? And then you guys could use your calculators from this point, but since I'm not using a calculator, I would multiply by -1 just so that my first term would be positive. This is an equal sign right here, by the way. And this would be 2 cosine squared theta plus cosine theta minus 1 equals 0. And then I would go ahead and do my substitution and make it x. So you guys would save yourself a little bit of time not having to do this. Okay, so we now have cosine theta equals 1/2 and cosine theta equals -1. So where is cosine positive? The right side, so 1 and 4. And where does it equal 1/2? 60. That's our reference angle. Okay, and then where's cosine -1? 180. So you've got theta equals 60, 300, and 180 degrees. Okay, number 12. What's the first thing you should have done here? Change everything in terms of sine and cosine. Okay, then what would you have done? Multiply by cosine. And you get 6 cosine squared theta plus 7 sine theta equals 1, but you also have to make sure that cosine theta never equals 0 because it's on the bottom of the fraction. So we write a little note. What would make cosine theta 0? What angles? 90 and 270. So I write a little note off to the side so I know at the end I need to check to make sure 90 and 270 are not one of my answers. Okay? Now this problem is exactly like the problem we just did. We've got a cosine and sine, but we've got a cosine squared here, so I can take the cosine squared and change it to what? 1 minus sine squared. I'm also going to go ahead and subtract the 1 over now because I know I'm going to have to do it. Okay? Okay? Distribute. Put my like terms together. And then since I'm factoring, I would multiply everything by -1, so my first term would be positive. Okay. I would let sine theta equal x. And then I would factor. And that should be a 2x there. Well, because -5 times a positive one would give you a -5 in the end.
Negative minus 1.
That's a lot.
This would be x equals 5/3 and negative 1/2. Okay, now let's move up here. So that means that sine theta equals 5/3 and sine theta equals 1/2, negative 1/2. Okay? Well, what can you tell me about the sine theta equals 5/3? We can't do it. It's bigger than 1. It's not going to work. But this one we can do. Where is sine negative? 1/3 and 1/4. And where does it equal 1/2? 30 degrees. So we've got theta equals 210 degrees and 330 degrees. And then we check to make sure 90 and 270 isn't in there, and it is not. All right, number 13 should not be one of the more difficult problems. All you should do here is divide by square root of 3, and you get secant theta equals 2 over square root of 3. Well, what can I do now? Flip both sides. And when secant is flipped, what does it become? So you have cosine theta equals square root of 3 over 2. And so we do the same thing we've been doing. Where is cosine positive? 1 and 4. And where does it equal square root of 3 over 2? 30 degrees. That's our reference angle. So you get theta equals 30 degrees and 330 degrees. All right, this problem is similar to number 12. You're going to change everything in terms of sine and cosine. And then what are you going to do? Multiply by sine. And you're going to end up with 2 sine squared theta plus cosine theta minus 1 equals 0. And we need to make sure that sine theta doesn't equal 0 because it's on the bottom of a fraction. So what can theta not equal? 0 and 180. Okay. Now, this looks like problems we've already done. What do I have to change right now? The sine squared. It's going to become 1 minus cosine squared theta, one of your Pythagorean identities. Okay? Distribute. Put your like terms together. And then since I'm not using the ACT program, I would multiply by negative 1 to make it a little bit easier to factor. And then I would use substitution. Okay. And let's go back over here. So now we have cosine theta equals negative 1/2. And we have cosine theta equals 1. Right? So where is cosine negative? Second and third. And where does it equal 1/2? 60. That's our reference angle. So we got 120 and 240 here. And then where is cosine 1? 0. So looking at this, we have theta equals 120, 240, and 0. But what do we have to make sure we do next? We have to cross out the 0, because up above we said that theta can't equal 0 or 180. So this 0 won't work. So theta equals 120 degrees and 240 degrees. On this problem, you have cosine and sine. Neither one of them squared, so we can't change them. So what did I tell you you're going to have to do? You're going to have to end up squaring both sides. But the first thing you should probably do, you don't have to, is I like to keep cosine and sine on opposite sides of the equal sign if I can. You don't have to, but I think it makes it a little bit easier to work with. Okay, then we would square both sides. Okay, which means that this is sine theta plus 1, sine theta plus 1. Okay, so now you've got cosine squared theta equals sine squared theta plus 2 sine theta plus 1. That's the whole FOIL thing. First outside, inside, last. So now I've got all these sines on the right and a cosine squared on the left. What can I do with that cosine squared? I can change it to 1 minus sine squared theta. Okay, and then I'm going to put everything on one side. And I end up with 2 sine squared theta plus 2 sine theta equals 0. Can I factor something out of all the terms? I can factor out a 2 sine, which leaves me with a sine theta plus 1. Okay? So if I set all my factors equal to 0, then what does sine theta equal here at the first factor? 0. What does sine theta equal in the second factor? Negative 1. Okay? So then, sine is 0 at what angles? 0 and 180. And where does sine equal negative 1? At 270. What do we need to make sure that we do anytime we square both sides? Check your work. So when you plug them into your calculator, do any of them not work? I'm pretty sure at least one of them does. 0 works when you plug it in. 180 does not work when you plug it in. So your answer is just theta equals 0 and 270 degrees. All right. Okay, number 16, these problems that are the multiple angle problems, which means the ones that have a number in front of theta, these are the ones where that number in front tells you how many columns of answers you have before you start to solve. Okay, so this is tangent 2 theta equals negative 1. The first thing you need to do is figure out which quadrants tangent is negative in, which is what? 2 and 4. And then where does tangent equal 1? 45 degrees. That's your reference angle. Okay, so here's an angle, and here's an angle. So right now we've got 2 theta equals 135 degrees, and we've got 2 theta equals 315 degrees. Okay, and these we write vertically because we're going to make columns. So what's the number in front of theta? 2. So how many columns should we have?
2.
And how do I get the second column? Add 360. So this one will be 2 theta equals 495. And this one down here will be 2 theta equals 675. Just add 360. And then to find our answers for theta, all we have to do now is what? We divide everything by 2. Because of the 2 in front of the multiple angle in front, we got to keep adding 360, and as long as we're under 720. All right, so theta equals 135 divided by 2 is what? It's 7.5 degrees. 315 divided by 2 is what?
7.5.
Okay, is that right?
Yeah.
495 divided by 2. And then 675 divided by 2. And all of these answers for theta work for the instructions, which said that theta has to be between 0 and 360. They're all between 0 and 360. Okay, so on 17, you've got sine 3 theta equals negative 1/2. So the first thing we have to do is determine what quadrant sine is negative in. Third and fourth. And then, where is sine 1/2? 30 degrees. So that's our reference angle. Okay? So we've got 3 theta equals 210 degrees, and we've got 3 theta equals 330 degrees. Okay? What's the number in front of theta?
3.
So how many columns are we going to have?
3.
Okay? So all I have to do is keep adding 360 until I get my 3 columns. So my next column would be 570, and down here would be 690. And then my third column, I add 360 again, and I get 930. And I add 3 theta again, and I get what, 1050? And then to get my final answers, all I have to do is divide everything by 3. So I end up with theta equals 70, 110, what is that, 190? 230, 310, 350. And all of our answers are all between 0 and 360 degrees. All right, number 18, what's the first thing you notice about this problem?
Yeah.
It's got cosine, sine, and specifically it's got a double angle, right? How many double angle identities are there for cosine 2 theta? There's 3 of them, so we have to choose which one is right or easiest to use. So we look at the rest of the problem. Well, what does the rest of the problem have in it? Sine. So we want to use the one that has only sine in it. So the cosine 2 theta that we're going to use is 1 minus 2 sine squared theta. Minus 3 sine theta minus 2 equals 0. And then we're going to put our like terms together. This 1 in the front and the negative 2 in the back there. Okay, then if you all wanted to use your ACT program, you could go ahead and do that from here. Since I'm not using the calculator, I would multiply by negative 1 to get my first term positive. And then I would do substitution. And factor. Oops. Okay, so you would have skipped all that stuff if you used your ACT program. So now I have sine theta equals negative 1/2, and sine theta equals negative 1. Where is sine negative?
Left.
3 and 4.
Oh.
Where does sine equal 1/2? 30, that's our reference angle. And then where is sine negative 1? Sine. 270. And you go down. So then theta equals 210 degrees, 330 degrees, and 270 degrees.